Hello and welcome to the Demonstrating Implementation Excellence stream of the SNOMED CT Expo 2020. My name is Terence Sherd and I'm the Technical Operations Manager at SNOMED International, and I will be moderating today's session. If you have any questions for the presenter during the session, please use the Q&A box and we will answer them at the conclusion of the presentation. I'm now pleased to introduce Michael Lawley from the Commonwealth Scientific and Industrial Research Organisation, CSIRO, who will be presenting Snowed In, Panic Coding During COVID Isolation. Michael, it's over to you.
Thanks, Terence. Hello, everybody. So this presentation was motivated by requirement to support subsumption testing with post-coordinated expressions and expression libraries with a deadline of 7 weeks and at the start of our COVID isolation. So I thought it would be a good topic for a talk, as it was an exploration into how post-coordination might be supported in the FHIR standard. So just an overview for the talk. I'm going to do a very quick refresh of post-coordination basics, the syntax and uses. I'll talk through what FHIR says about support for post-coordination in SNOMED, and then I'll look at what we have actually implemented and how it works and where some of the limitations are currently, and then I'll take a step back and look at the gaps and limitations in the various specifications involved and what's required for future work. So post-coordination. Post-coordination basically provides a simple grammar that allows you to combine multiple codes so that you can say something more than you can say with a single code. So here you might be specifying some additional detail, such as laterality or severity. You may be providing a more precise anatomical site. You may be combining two different concepts together to produce a composite concept. Under the hood, what you're actually doing is expressing a description logic expression, but you have a simplified syntax for doing so. So if we look at a couple of examples here, I've left all the concept IDs because they don't provide clarity. So you can just combine two concepts together, so spray dose form and drug suspension. It gives you an expression that means something that is both a suspension and a spray dose form. You can refine fracture of tibia with a left laterality or right laterality. You might want to narrow the site of a tibia fracture down to a particular part of the tibia. What does the syntax look like exactly? Well, it looks something like this. You'll see a lot of punctuation in there, colons and curly brackets and so forth. The labels on the concepts. The labels take no part in the expression, just they're there for human readability. But if you're familiar with the diagramming syntax, you'll see that actually the structure is very similar to the diagramming syntax. And for some signposts, you'll see that the little roll group circle there matches up with these curly brackets. So if you're familiar with the diagramming syntax, it's not actually too much of a stretch to understand what a post-coordination expression looks like and to write one yourself, as long as you understand the concept model and what's valid. So now let's look at what FHIR says about post-coordination. And FHIR has a page dedicated to, explicitly dedicated to support for SNOMED CT, and it contains this particular section. So the following artifacts are valid in the code elements for the SNOMED namespace: a concept ID, good, that's what we expect, but also SNOMED expressions using the post-coordination syntax. So first-class support for expressions in FHIR. Anywhere you can have a SNOMED code, you can have a SNOMED expression. What else does it say? Well, it has something to say about the display text for expressions. Basically, it says there is no defined display text for an expression, but if a publisher of an expression repository, whatever an expression repository is, provides display text, then you can use that. Or if there are templates for generating them, you can use those, but otherwise there's no further guidance. And actually, that's pretty much all that's said in the spec that's specifically about post-coordination FHIR. But the question then is, well, how does using post-coordinated expressions actually impact on the various APIs that are provided? So a number of APIs that could take a post-coordinated expression or be affected by expressions. Code system lookup. So when you look up a post-coordinated expression, what should you get back? Validate code. If you validate a SNOMED expression, what should you get back? Validate code on a value set. So this is doing a validation of the expression, but also asking, is that expression a member of the value set? Then we've got some subsumption testing operations. So that goes back to the brief of support subsumption testing. So subsumes and provide two codes, either of which may be expressions. Does one subsume the other? And then closure, which allows you to provide a set of concepts and expressions and return the subsumption graph. And then finally, value set expand. So expanding a value set and getting back post-coordinated expressions in the result. How might you get back expressions in a value set expansion? You don't normally do that because, well, there's potentially an infinite number of them. Well, if the value set definition explicitly included an expression, you would expect to get it back in expansion. But there's another mechanism whereby you might get post-coordinated expressions returned, and that is via the code system supplement. So a supplement in FHIR allows you to provide additional properties of a code. It doesn't allow you to define new codes, but we would argue that all post-coordinated expressions are already implicitly defined. So if including them in a code system supplement is not really defining new ones, it's merely stating their existence. So given a code system supplement containing post-coordinated expressions, then a value set that references that supplement, you might expect that its filter expressions or an ECL expression would match against those post-coordinated expressions. That's the spec. And of course, we had 7 weeks to do this. And fortunately, or unfortunately, we went into lockdown. So a bit of focus was available and off we went. Now, luckily, we were in the modern era of SNOMED and we have an OWL-based stated form. So we don't need to take the OWL definitions, the RF2, and transform it into description logic expressions. We've got them out of the box. And there are some excellent open source description logic classifiers that are available, and they support the notion of incremental classification. So you can classify all of SNOMED, and then you can add in new expressions and just classify those so you get a much faster turnaround. So this is ideal because that's exactly what we're doing when we're post-coordinating. So these two pieces were the key enablers for producing, well, okay, it didn't take us 7 weeks to produce 610, but we did get the core of the post-coordination behavior implemented in that time window. So what does it look like? So we'll start with the easy case, look up with a post-coordinated expression, and Here's an example invocation. We're providing SNOMED as the code system, and the expression, no white space, no labels. This is part of the specification of the API for these operations, is that expressions should not have white space or labels in them, or extraneous white space, I should say. So this is what an invocation would look like. And what would we get back? Well, we get back a parameters result. And in our case, we do provide the details of the code system, so SNOMED, SNOMED version that we used, and then the display text. And so we've opted to generate display text for expressions, and we basically use the same syntax. We just replace all concept IDs with the associated preferred term. So what do you notice about this? Well, we're doing a syntax check. So if you provide an invalid, syntactically invalid post-coordinated expression, then you will get an error coming back. So it'll fail to look up. You do get back the display text, which is useful. We normalize the order of the refinements, so you get them back in a consistent order. What we don't do is return any properties. So we've opted for a minimal implementation here, simple and fast. There's no sort of extra processing that goes on, no incremental classification and so forth. And this is the first part of the implementation. And as we get experience with what people really need, we'll be expanding out the implementation. So the next operation is Validate-code. Validate-code has no explicit additional behavior specified in the FHIR specification. So we had to work out, well, what should it do? So what we opted to do was, again, validate the syntax. But we also validate each of the component codes. So we check that each one is also, so effectively we do a validate code on all of the contained codes in the expression. We opted not to do machine readable concept model validation. A couple of reasons for that. One, we didn't need to. But secondly, the MRCM can be operated in multiple modes. So the question was, which mode should you operate this in? We decided to punt on that and leave it open. Now, because we were doing validate code on all the subcodes, we wanted to return the results. If a subcode was not valid, we didn't want to just say, well, the whole thing's invalid and not provide any additional details. So we opted to provide extended results beyond just the Boolean true false. So this is what we did. This is a work in progress. It's not ratified. We need to socialize it with the community and see how people feel about this. But essentially, we do a result for the expression as a whole, but for each component part, we also do a validation result. So you get to see for each of the pieces, is that code valid or not? So it takes us to subsumption. And with subsumption, the invocation, you provide two codes, one or either of which may be an expression, and you get back a subsumption result. So this is where the incremental classification comes in, and this is what we've actually implemented. So if you provide a post-coordinated expression or two, the classifier will be run to do the full subsumption testing. Of course, the usual behaviors that you would expect apply. So changing the order of refinements where it doesn't affect the semantics. So you'll get equivalence as a result. That's all normal. And closure is just really an extension of that. Instead of working with 1 or 2 expressions. You may be working with n expressions. Again, we do incremental classification to update the subsumption hierarchy, and it all just works as you would expect. And it's reasonably quick too. I don't have a live demo prepared, but we're talking a couple of seconds for a result, which is pretty useful. So what about this notion of supporting an expression library? So our option here was we decided to use the notion of a code system supplement. It's a FHIR artifact where you can list multiple post-coordinated expressions. We can also associate display text because we are just listing concepts with associated display text. So that's quite handy. And once you've got a post-coordinated expression library expressed as a code system supplement, it can be referenced by a value set. And that then means that when you do an expansion, you know that those expressions are in scope for being matched by the expansion. So here's an example of a code system supplement. Zoom in to show. You see that the content is of type supplement. It supplements a particular version of SNOMED, and then in the list of concepts, we've got a whole lot of post-coordinated expressions. And we've been relaxed here. We allow expressions containing display text to be included. Makes the library a bit more readable. And you can see there an example of an expression that has, well, not very useful, but has display text associated with it. So when we have this, we can do an expand on a value set, and we'll get back post-coordinated expressions in the result. We can't provide alternate identifiers for expressions, or at least we haven't adopted a standard way of doing that. Because it's a supplement, you can give these things additional properties. So that's okay. And there is a particular FHIR extension that allows you to indicate an alternate code. But this has no formal status for use within the for use with SNOMED in FHIR. And the FHIR spec actually says that the RF2 alternate identifiers are explicitly excluded from use in FHIR. So probably this extension is the path to giving expressions an identity of their own. But we haven't done anything with exposing that through the FHIR API yet. So if we look at now at some of the gaps that exist, there's some unspecified behavior in FHIR with respect to equivalent codes. This is not limited to post-coordination in SNOMED. It actually manifests in other code systems, usually those that are grammar-based. And there are rules in FHIR that, for example, an expansion should not have repeated codes. But if you've got equivalent codes, are the two different versions of the same code repeated codes or not? What happens if those equivalent codes have different display text? How do you merge those together? How do you merge their synonyms together? This is all sort of a grey, untested area of the FHIR specification. We need to make sure that we do proper code normalization. So, for example, the order dependence in the expression. And that means that clients need to be very careful when working in this space, because suddenly you can't test code equivalence by testing code equality. You really do need to use the terminology service to test for equivalence. And then there's some issues around the closure operation. If you provide equivalent codes into the closure operation, should they be treated as the same code and thus one of them chosen in preference to stand in for all the others, or should they be treated explicitly as separate things? And probably they should be treated separately. But again, the behaviour here is not fully worked out. If we now turn to gaps related to the SNOMED specification, post-coordinated expression syntax was reasonably recently extended to support the idea of a subtype expression. So this is an expression that is preceded by 3 less than symbols, and it indicates a concept that is has a meaning that is a subtype of the actual expression itself. But it doesn't say what that meaning is. So the consequence of this is that 2 syntactically identical expressions with this triple less than syntax are actually potentially different, represent different meanings. And so they don't subsume each other. So strictly, if you do a subsumes, as shown here, the result should be not subsumed. Question is that the behavior that we want? And I think in practice, sometimes it is what you want, and sometimes it isn't what you want. And when it isn't what you want, really you're in a world where you want to be able to provide an alternate identifier for the expression. But as we mentioned earlier, we don't have a mechanism for specifying and then using these alternate identifiers. So the other another gap relating to SNOMED relates to the inconvenience of role groups and the notion of a close to user form of post coordination. So I skated across this at the beginning when I was introducing post coordination, and that was quite deliberate. Many of the examples of post coordination provide something like laterality example. So you want to say fracture of leg and say it's actually the left leg. But this expression, as specified here, is not valid with respect to the concept model. Laterality applies to bone structures, not to findings. And so the proper expression is actually a much more complex thing. And it's tedious to specify, and hence it's not really convenient for the user. So there has been a proposed transformation from a so-called closed user form to a normalized form, which deals with these sorts of syntactic transformations. Problem is that the current specification of that is buggy. It contains some non-deterministic steps, and it can lead to invalid expressions. So at this point, our implementation, we opted not to support close to user form. We will probably implement some form of transformation over time, but in a very conservative manner, because we want to not give people invalid results. One of the things where this transformation becomes problematic is when you have multiple sites that you might attach the refinement to, and then there are some other issues as well. So if we look at refinement of a site, we want to refine fracture of leg to site of the tibia. Well, that's okay, but if we had a procedure where the definition of the procedure used either procedure site direct or procedure site indirect, then our refinement of procedure with procedure site and a refined procedure site would be difficult to apply, because procedure site is a supertype of indirect or direct, and so the transformation doesn't properly apply. And this is where things start to become non-deterministic and problematic. So that's why we've opted not to do that. The other reason is that the documentation in this space is sometimes wrong, sometimes misleading. So an example here, you have a statement that these two expressions are equivalent because of the role groupings are the same group, but this is incorrect. Procedure has no role groupings, so the two expressions are just not correct, not equivalent. So there's a bit of work to be done in this area of the spec, and hopefully now that we have some work going on implementing post-coordination, it will motivate refinement of all this work. So finally, some limitations of the implementation. We have a limitation in Onto Server that all value sets have to explicitly reference a supplement to be able to match a post-coordinated expression. This is actually just the normal limitation of code system supplements, is that value sets have to explicitly reference the supplement for it to be considered in scope when you do an expand. We have an additional requirement that you have to specify the specific version of the code system. That's just a technical limitation. Not all of the filters that you specify in a value set definition interact appropriately with post-coordinated expressions. So filters with hierarchy currently work. Those that are matching on relationships, so are looking at basically the refinements in the post-coordinated expressions, they don't work. And as I said, we don't have any support for close to user form. So in conclusion, at the end of this implementation process, I'm with Ed on this. I actually have no love for post-coordination. It's got a lot of ugly bits, but it is a really sexy idea. And time will tell as to whether or not support for post-coordination is a useful thing to be doing. Thank you very much.
Thanks very much, Michael, and thank you for your informative presentation. Can I just ask that attendees give us a moment while we switch over from our pre-recorded content so Michael can address the questions that you have been submitting live during the presentation. I would also like to remind attendees that this session will be available on the event platform for the next 3 months if you want to watch it again later. Thanks very much, Michael, for that in-depth discussion on post-coordination. I'm quite aware we've had quite a few queries from people during the conference already about post-coordination. So I know it's, although you commented at the end of the slide, but I think a lot of people seem to be interested in it. And we have a few questions as well, which I think supports that. So first of all, Michael, can you sort of answer how you would validate the expression, particularly against the MRCM, especially if it's a long list?
So I'm not quite sure what the long list reference is, but we've chosen not to validate it against the MRCM because we can't make an assumption about which mode or which set of MRCM constraints to apply, whether they're authoring constraints or non-authoring constraints, as it were. We may do that down the track. It really, this is a first pass, and we need to get some experience with just how people want to use post-coordination and what's a useful semantic to apply.
Yeah, thanks. Could you please elaborate further on code equality is not the same as code equivalence?
Okay. So code equality, that's just looking at the surface syntax. So you look at the string representation of the code, and you say if I've got two equal strings, then I say they're I can say they're equal, but I can't know whether or not, if they're not syntactically equal, they may not be, they may still be semantically equivalent. So the simple example of that with post coordination is just a post coordination of code A plus code B is equivalent to code B plus code A, but those two strings are not equal. It's a bit trickier when you have the triple less than to say it's a primitive subtype, so it's an anonymous subtype of the focus concept, because then you do have equal strings, but they're not equivalent.
Okay. Someone here has got some classification and mapping background and has asked, does an expression library preclude mapping to ICD-10?
No, it doesn't. So generally maps are built by, maps are built code by code. And so if you've got a mapping library, you've got an explicit list of expressions, and so you can equally just map those expressions. And because FHIR treats expressions equivalently to single codes, you can express that in a FHIR concept map. If you've got a more expressive mapping language where you can do like rule-based maps that use subsumption, for example, then because a terminology server like OntoServer provides subsumption support for post-coordinated expressions, you can use that to do the mapping that way.
When using code system supplements to represent post-coordinated expressions, will you then have to perform two value set expand operations to retrieve both pre and post-coordinated expressions?
No. So the way value sets work with code system supplements is that when you define your value set, you simply add in a reference to the supplement that you want to bring in scope. And then if you sort of think about the notion of substrates, it basically takes the substrate that is the supplement plus the substrate that is the code system, evaluates the value set against the combination of the two.
Okay, what's your view if we allow to automatically assign SNOMED CT IDs for post-coordinated expressions?
So that's an interesting one. So I guess you would, if you do that, you have to have some kind of sanctioned, well-known process for assigning IDs to post-coordinated expressions. And you would also need to be careful to deal with, again, those primitive subtype variations, because you would need to be able to assign an ID to one of those that could be reused, and you would also need to be able to do it so you get the same ID for that case. So there's some tricky corner cases there, but I think it's doable up to a point.
Okay, thanks very much, Michael. Unfortunately, we've run out of time for more questions. There's still a couple more on the board. Unfortunately, we haven't got time to go through them now. However, Michael is available in the exhibit room. There is a CSIRO stand, an OntoServer stand inside the exhibit booth, so please pop along there, and I'm sure Michael and his team will be available to answer any questions and any detailed sort of implementation type stuff that you want to discuss. Thanks very much, Michael, and I hope the rest of the attendees enjoyed the discussion, and I hope that you enjoy the rest of what we have in store at the Expo for you today. Thank you very much, and bye-bye.